Hi, and welcome to our lesson on geometric sequences. Okay, so you should remember that in arithmetic sequence, we're adding the same thing every time, so we'd add 2, add 2, add 2. Geometric sequence, we're going to go 1, 2, 4, 8, 16. So notice that in this case we're multiplying by the same thing every time. So times 2, times 2, times 2, times 2. On part B, we'll be multiplying by 3 every time, times 3 times 3. Okay, so what is a geometric sequence? Well, we multiply. By the same thing. Okay, and same as before, our first term is called A, and the amount we multiply by every time is called the common ratio R. Okay, so let's have a look up here. So for this one, our first term is 1, and our common ratio, the thing we multiplied by every time, is 2. Notice that if you're having a hard time finding the common ratio, you can take any term and divide it by the term before it. So for example, in A here, we could take, say, 8 and divide it by 4, and that would give us 2. Okay, so here we go, part B. Our first term is going to be negative 2, and we can see we're multiplying by 3 every time. Okay, part C. Our first term is going to be 8. And now, what are we multiplying by every time? Well, maybe not so easy to tell. So let's just take any two terms and divide, or take any term divided by the one before. So I could say take negative 4 divided by 8, and I can see that my common ratio is negative 1/2. Notice that you may be tempted to think about that as dividing by negative 2. It's best to think of it as multiplying by the same thing every time. So in this case, it would be multiplying by negative 1/2. Okay, question 3 asks us, what do the 3 dots mean at the end of the sequences? And it means that they go on forever, which you probably knew. Okay, in a convergent geometric sequence, the values approach 0. If not, it's called divergent. Okay, so we need to label these guys as convergent or divergent. Well, clearly in A, the numbers just keep getting bigger and bigger and bigger. So that's going to be divergent. Okay, and in B, they're going to keep getting, I guess, smaller, if you want to call negative smaller. Either way, they're not getting anywhere near 0. So that one's also divergent. Notice in C, our fractions keep getting closer and closer to 0 every time. So an eighth is closer than a quarter. Negative a 16th will be closer than an eighth. 1/32 will be closer than that. So in this case, we keep getting closer and closer to 0, so this guy is convergent. Okay. So, oh, sorry. I guess we shouldn't have called this first guy divergent because he doesn't go any further past 16. But yeah, so B is divergent, C is convergent. Okay, notice the general rule for things being convergent or divergent is that if your R is between -1 and 1, then you're going to be convergent. Yeah, notice also that of course R wouldn't be 0 because you'd just end up with, you know, like 1 and then everything, or your first term and then everything after that would be 0. So this, the reason we don't even bother saying that is because it's never going to happen. Okay, so here's our first example from the book. They want us to determine the 12th term of this sequence. So first thing we can see is that we're multiplying by negative 1/2 every time. So our R is negative 1/2. So our 12th term is going to be 5/12 and then we need to multiply by negative a half 11 times. If we multiply by it once, it gets us to T2. Multiply twice gets us to T3. So to get to T12, we're going to have to multiply by negative a half 11 times. Well, the easy way to write that is negative a half to the power of 11. So that's going to give us 512 over negative 2048, which is negative a quarter. Okay, and because our r is negative a half, that's between negative 1 and 1, that means that we're going to be convergent. Okay, and this wants us to give a formula for the nth term. So Tn, we'll start with our 512, and then we're going to take negative a half to the power of 1 less than n. Right, because if we multiply by negative a half once, that'll get us to T2. So if n is 2, that T2 would mean n minus 1 here. We'd multiply it by negative a half once. And here's another similar question from the book. So we need to figure out r. Again, oops. Again, if you have a hard time figuring out r, just take any term divided by the one before it. In this case, our r is going to be negative 3. Okay, and they want to know T10. So T10, we're going to have our original 2, and then we're going to have to multiply by negative 3 9 times. So T10 is going to be negative 39,366. Okay, in this case, our r isn't between negative 1 and 1, so we're going to be divergent. And for this guy, Tn is going to be 2 times negative 3, and we're going to have to multiply by 3, 1 less than the term number. So generally, our Tn is going to be a times r to the n minus 1. And you will be given that formula on tests and quizzes. Okay, question 3. We've got a geometric sequence. They've given us T1 and T5, and they want us to figure out T2 and T6. Okay, well, the best way to do this T3. So here's the ones we know, 7 and 567. And to figure out r, we need to know that to get from there to there, we're going to multiply by r. There to there, multiply by r. There to there, multiply by r. And there to there, multiply by r. So I'm going to have 7 times r 4 times is going to equal 567. Divide both sides by 7. I get r to the 4th equals 81. I'm going to take the 4th root of both sides, and I get the absolute value of r equals 3. Oops. So r is going to equal positive or negative 3, which seems kind of weird, but let's see how that works out. So we've got two possibilities here. Either r equals 3, in which case we'll have 7, 21, 63, 189, 567, and 1701. And they wanted T2 and T6, so those are the two values the question asked for. Or our other possibility is r equals negative 3. So they'll give us 7, negative 21, 63, negative 189, 567, and negative 1701. And again, those are the two values the question was looking for. Notice that the values we were given, the 7 and the 567, work with both possibilities of r equal 3 or negative 3. So our T2 is going to equal positive or negative 21, and our T6 is going to equal positive or negative 1701. Notice if they would have asked us for T3, T3 has only one possibility. It's going to be 63, no matter what happens with r being positive or negative. Okay, now let's have a look at part B. So they tell us the last term is this, and they want to know how many terms in the sequence. So I'm going to use Tn equals a r to the n minus 1 to figure out how many terms there are in the sequence. We know our first term is 7. Okay, we've got a bit of a dilemma here. Should we use 3 or negative 3? Well, I'm going to use 3 just in case this is, say, for example, an even numbered term. So let's say this is I don't know, 12. Because you remember when r was negative 3, T12 would have been negative. So there's a chance that r is actually 3. So we want to account for that by using a positive 3 here. Okay, so we divide by 7, and we get 65, 61 equals 3 to the n minus 1. And we now need to guess and check in our calculator, and we see that 3 to the 8th is the same as 3 to the n minus 1, or equals 3 to the n minus 1, so we get 8 equals n minus 1, add 1, so n equals 9. Okay, because n equals 9, that doesn't help us decide whether or not r is negative 3 or 3, because all of our odd terms are positive. So on the upside, we figured out that 45,927 is the 9th term, but we still don't know if r is positive or negative, because either way, the 9th term would be positive. Okay, here's a little question about Airdrie, Alberta, just outside of Calgary. And it says they experience an average annual growth rate of 9%. Okay, and they've given us the population in 2006, and they want us to find out the population in 2011. So 2006, 2007, 2008, 2009, 2010, 2011. So it's going to be T1, T2, T3. Okay, so notice that we're looking for T6. Very common mistake in questions like this is people go 2011 minus 2006 and assume they are looking for T5. Hopefully everyone can see from this little diagram that that is wrong, and that we're actually looking for T6. So T6 is going to be 28,927, and that's going to be 6 minus 1. And now we just need to figure out what we are multiplying by every time. Well, a growth rate of 9% is going to, for 2007, is going to be our original 100% from 2006 plus another 9%. So we need to multiply by basically 109%, or 1.09. Okay, and that gives us a T6 of 44,569 rounded. Okay, so that was part A. Part B, we need the population for 2030. So notice if I go 2011 minus 2006, I get 5, but then if I add 1 onto it, I get T6 like I should. So if I go 2030 minus 2006, I get 24. Add 1 onto it, that tells me that 2030 is going to be T25. And that gives me 228,844 people. And now they ask us for what assumption did we make? Well, we're assuming that the population is going to go up 9% every year. Is this assumption reasonable over that span of time? I think there's way too many variables to assume that the population is going to increase like that. You know, you could have massive flooding, you could have the economy in that town go terrible and everybody leave. There's a million factors that could happen. So no, I don't think this is a reasonable assumption.